All right, so I have got two of these units. Now on one, I've already done the modification. So if I plug in USB, you can see it turns on. So I'm gonna go through the whole process on this just as I'm doing it so that you can see exactly what the process is. So a lot of it might feel like kind of dead air, but I thought I'll capture it all so that then that's as useful as possible for you. So first, take these screws out. There's 6 of these underneath. Get this, I'm going to set this aside, take these buttons off so they don't fall off and go everywhere, and then loosen these jacks here. Set this aside. All right, then we can take this board out and put the bottom part of the enclosure aside. Now there's these light pipes for LEDs and these button actuators. We're gonna also set those aside so they don't fall out somewhere and we lose them. All right, so I did a bit of reverse engineering on this, looking at the power path. I didn't kind of completely go through every single step, but I'm gonna show the important part. So power jack DC comes through here. We've got some reverse polarity protection and it goes through some filtering capacitors here. And then goes into this power muck switch also. I couldn't find the exact part of this chip, but from probing some voltages, looks to be a power mux, perhaps with a built-in voltage regulator. Now you've also got the batteries, so that the positive terminal goes through here, has a trace going underneath the board through a fuse here, which comes out the other side from those vias, jumps over to here, and then we have like a power selection switch here, which comes in, and then there's a buck boost voltage converter regulator. Here you can see there's an inductor here, so this is our switch mode supply, which generates a steady 3.3 volts regardless of the battery voltage. So there was a few different ways I considered doing this mod to allow power via the USB port here. If you look here, this pin right here is the 5 volts pin. It's not connected to anything on this. So yeah, there's a few different approaches, and what I wanted to do is make sure that all the existing power options continued to function. So there's a few different steps going on here. I initially tried ORing with a diode the power from this USB receptacle into this path, but there appeared to be, if there's a linear regulator in this chip, the 5 volts was too close to the output of that there, and it was causing some interesting behavior. To do this, I guess most properly, if you were wanting to design it from scratch, you would add some additional power pathing and muxing, but I wanted to make this as simple as possible. 2 goals: as simple as possible for someone to perform using pretty standard components and not require having to mount integrated circuits glued to the board and running wires everywhere. And I also wanted it to be as non-destructive as possible. So the best approach that I found for this after some trial and error is to take a tap from this battery input. So this chip here is a buck boost converter. So whether the voltage is lower than 3.3 volt output voltage or higher, it will convert it to that 3.3 volt. And looking up the part number for this chip, I believe it's a Texas Instruments TPS 6030, something like that. I can't remember off the top of my head. but it has a maximum input voltage of 5 volts, which is pretty standard for all these type of chips. So this seems like our safest play. So what I did on our existing unit here, which I've already done the modification for, is remove this fuse. Now this fuse is just there for some battery protection, so that for different chemistries, it's there. It's a little bit redundant. And from your use case that you described, you're powering from either like the DC jack or the USB port. So this makes the process quite reversible. So what we really need is to allow for battery operation, power jack operation, or USB operation. So without, as I said, the proper way to do this would be a bunch of like extra components, but the simplest and also least destructive approach is going to be to add a power OR. So what that means, power OR, means that if there's power applied by batteries that you might have in there, as well as the USB port, you only want it to draw from one, so you don't have any voltage feeding back into one of those power supply sources. So to do that, we can use 2 diodes. So I'm going to remove this fuse here and put a diode in that place, because that's a series component, and I didn't want to be cutting these traces and then putting a diode across there as well, which then is a slightly more destructive process. So removing the fuse is not ideal. It's there for protection, but the actual protection it provides in a battery setup is more there for redundancy, and I felt it was the simplest approach for a mod like this, where you want a video so that you can do it to other units as well without requiring any esoteric parts or destructive processes. So we're going to put a diode across there. Then we're going to put a little diode, or the same diode I should say, but connected to this power pin here, and then run a wire over to tie the ends of these 2 diodes together, which feeds into the input of this power protection. That's looks to be a MOSFET for some reverse polarity protection, and then goes on into our voltage regulator there. So first step will be removing this fuse, and it's just a small surface mount fuse. It's nothing special. You can get it at any electronics distributor. So it's the part that makes the most sense to remove, as far as being able to revert it to the stock configuration if you want to. So all of these steps can be fairly easily done. Now this will use a lead-free solder, so I'm going to just have to apply some extra solder to these pads. Turn it this way, and I don't want to apply a hot air gun to this to desolder that, because it's going to be very loud and noisy on the video. So I'm just going to kind of alternately heat up these pads until there's enough heat in the part with this leaded solder, which is a lower temperature, for the part to slide free. So we can, there we go. All right, so we've got our fuse here. What a mess I made there. All right, so you can see we've got this fuse here. Let me get rid of that extra solder from it. And again, in an ideal world, it would have been nice to keep that fuse in with the battery path. It is a little redundant. It's something you add in mass manufacturing to account for different like battery types and things like that. But I figured that the battery power option was going to be the least, critical for you. I don't know how well you'll be able to see that. I'll try and hold it up. It's large in terms of surface mount parts, but pretty small if you're not used to dealing with them. Okay, so I'm going into my parts box here. Take 2 of these diodes. Now I'm using SOD-123 Schottky diodes, which have a very low forward voltage drop. Now what this means is adding a diode in here is going to drop some voltage across it. It's only a few hundred millivolts. One downside to this is that if you are powering it via batteries, then the point at which the batteries are depleted is going to happen slightly sooner, because we do have some extra voltage drop across these diodes. So when the voltage drops too low, it will that power LED on just there will blink, will go red instead of green, indicating that the batteries are low. But that seems you're still getting most of the battery life, and that seems a pretty worthwhile trade-off for making this as simple as possible. So I'm going to apply this diode here. Now, the easiest way to look at this markings, if you're not familiar with a diode, for whoever's watching this, on these SMD parts, there is a little stripe on one end, and you can think of the diode like a valve. It only allows current to flow in one direction. So we want the current to flow from this positive terminal through the diode to this point. So I'm going to go in, just remove some of that solder that has blobbed up there from removing the fuse. Okay, there we go. Got my other diode on the finger. So now I'm just going to tack this diode in place on one of those solder pads. The nice thing why I chose this approach is the fuse, the PCB footprint is pretty much perfectly matched for this size diode. And a little bit more to reflow that tip. All right, so we've got this diode in place. Now, like I said, in a minute, we're going to then connect a small diode to that pin and then run a wire to bring it over to this contact point here, which is where there's these vias, which passes a trace up through to the top of the board and feeds into our polarity protection and everything else. Now, something to be really careful is for connecting this wire, we could connect it straight to this kind of solder point of the diode. One reason I don't like that is there's these three very small capacitors here, and there's a risk of accidentally desoldering those from heat, because they look to be 0402 parts? No, they look like 0201 parts. So they're very easy to accidentally desolder, and they're almost impossible to find afterwards, and I don't want to risk that. So in my opinion, the lesser of two evils is to scrape away a little bit of this solder mask, which is the green color you see, so that I can get to the copper below and then solder to that point. But where this LED is on the enclosure here, this is the light pipe for the power LED, and it actually is this rectangular footprint and is quite large. So to make sure there's no interference with that, that's the LED there, we need to kind of solder it right up here so that it doesn't cause interference with that. So I'm just going to scrape away a small amount of this solder mask now to reveal some copper below to give me a point I can solder to. So this might not be as easily visible, so I'll just go ahead and do this. You want to be careful that you don't scrape off too much of this, because then you can start to bite into the copper layer and actually kind of take too much of the actual copper off. And this copper layer is only quite thin, so I'm just scraping with like the flat part of the blade here to remove that. A little bit of a rough job, but it's going to do the job just fine. So now I can take my soldering iron and apply a small amount of solder to that area, and the flux in the solder is going to do enough of a job of cleaning that contact pad off. And that amount there, that contact area, is going to be plenty for our piece of wire to solder to and avoid any interference from the light pipe shroud for this power LED. So now we'll take our other diode, spin this around. We're going to solder it to the 5-volt pin of this USB receptacle. But first, again, because this would have been soldered with lead-free paste, I just need to apply a little bit of our leaded paste here, because it's going to be a bit easy to work with, and then take as much of that solder off on that contact as possible to reduce any defects that might occur from the mixing of the solder alloys. Again, you wouldn't do this for like a production, product, but for, kind of one-off like modifications, this is perfectly fine. So we're taking our diode, and now again, we want the two ends, we need to connect our diodes with the ends with the stripe on them. This is trying to be as non-technical as possible. Current's going to flow from a USB receptacle to this part here. So we're connecting the end without the stripe on it, without the polarity marking. Connect it to this USB pin, like so. Now, the strength of that solder joint is going to be more than enough to hold that diode in place. We don't need to worry about gluing it down to the board or anything. We'll apply a small amount of adhesive as strain relief for this wire that we're going to run, but we don't need to like glue that diode down or anything. Again, this is not how you would, do work for like a mass market product, but it's going to be fine. So I've just stripped the end of some red wire here. This wire is thicker than it needs to be. It's, you don't need wire this thick, but it's what I've got on hand, and I'm just trimming so there's only a small amount there. Now, to get good bonding between these joints, I need to just tin the lead of this component because it's only quite small. So now actually I'm just going to trim a little bit more of that end off so I don't have a big exposed contact point running across the board. Okay, that's got a pretty strong bond going on there. I'm going to run this wire first, and then I'm going to add a small amount of glue to 2 points on here to act as strain relief so that it's not putting strain on the that fairly fragile solder point. So cut more than we need off first and run it to length. So I've got to make sure I work this wire around where molds for these light pipes are. So I'm just going to run it up here and then to that point there, so we can trim it off here. Just give us a little bit extra, and then strip the tiniest amount off. Sorry for my head being in the way. We only want to strip this small amount off so we don't accidentally bridge any nearby contacts if we nicked a little bit of the solder mask that was on the ground pour. So I'm just going to run this with my hand, nice and flat. All right. Then use some tweezers to shape that so it sits right on top of that little solder island that we created. Then make sure I'm just pushing this wire down all the way when I solder it so that it's got the most contact area possible. Might just get a little bit more solder so there's some fresh flux in there, and give this a little bit of a touch up. All right. Now, again, is that the neatest job in the world? No. Is it going to be perfectly fine for this? Yes. Okay, so electrically, that's all we need to do. Again, you can see like that diode's moving a little bit when I kind of bend this cable, which is something we want to avoid because we don't want this wire to break off. So I'm going to add a little bit of glue there to hold it in place. Now, something you could do is use some like a pen applied solder mask resist onto like these points. You really don't need to do it. Yes, solder mask will prevent against corrosion, but this contact point is electrically sound, and I wanted to keep those points exposed so that if you wanted to undo this modification or something like that, you could. So first of all, we're going to test it with our USB cable. So I've got a standard DC connector here. Sorry, it's a little bit short, but we'll plug it in, and you can see our power LED is applied there in both kind of modes of this switch, working correctly. Then we've got our USB-C, sorry, our USB, where's a B connector here, and we'll turn it on we get our power LED in both modes. And because we've added these diodes here, even if I take a power supply here and plug it in, connect it to these battery contact points, this one here is our negative battery terminal. Oh, sorry, I don't have the power supply turned on yet for this exact reason. This yellow wire is our positive battery terminal, and this white wire is our negative battery terminal. So we've got our, flip this over, power LED on. I'm going to unplug this USB connector to show you the power on. Now I've got a bench power supply indicating it is essentially simulating battery voltage. So I've got it at like a low battery voltage around 2.8 volts, which is still within the operating parameters of what the buck boost regulator needs. And then if we plug our USB cable in, got no damage. That diode O-ring is going to protect both the batteries and the USB for any kind of back feeding of current, which we don't want. And then if I disconnect this, which would be like taking the batteries out, our power still remains on in both modes. All right, so I am just going to add a small amount of glue to glue this wire down to the PCB to stop it flexing and potentially ripping that diode off. So I'm just going to keep the wire up above the board so the glue can like flow underneath it. And then I quite like this glue because it's quite strong, but it dries and it's got like a bit of flex to it. I wouldn't recommend using super glue because it's quite rigid. And I'm just going to glue this down carefully near both ends to act as some strain relief on those solder joints. Again, this is very much the DIY approach, but as you requested, making this as simple as possible for a local repair shop to follow this process. Now, I'll just add something to hold that wire down so that it's going to bond without kind of lifting up from the circuit board. So that's going to take a little bit of time to dry. So in order to avoid a complicated, time lapse or something like that, all you are doing is then placing the circuit board back into the top part of the enclosure. So put the button caps back in. Then you need to put these light pipes back into the LEDs, and these button actuators just slide into the circuit board like so. Then you can reassemble the enclosure and you get your finished modification powering over USB.